Hey everyone, welcome back, and let's write some more neat code today. So today let's solve letter combinations of a phone number. So we're given a string of digits that contain only 2 through 9. So the digits are only going to contain the numbers 2 through 9. And we want to return all possible letter combinations that the number could represent. And so basically what this problem is about is like when you wanted to text people with old phones, you only had these digits, right? So in order to have characters, you'd map a number like 2 to the characters A, B, C. And you can see the reason we're doing 2 through 9 is because 1 was not mapped to any digits, right? So we don't need to consider the 1. 2 was mapped to ABC. 3 was mapped to D, E, F. Basically each number or each digit, 4, 5, 6, each one was mapped to 3 characters. Some were mapped to 4 characters. 7 is mapped to 4. 9 is mapped to 4 different characters. So then if you're given a string of digits, let's say 2, 3 in this case, right? 2, 3 is our string. Well, how many different output strings could we have? Here you can see we have a bunch, right? We have 9 different strings. Why do we have 9 different strings? Because this 2 could be 3 different characters. It could be A, B, or C. This 3 could also be 3 different characters, D, E, F. So 3 times 3 is 9. So basically we can have 9 different combinations of these characters, right? We could have A, D, we could have A, E, we could have A, F, right? And so on, right? So we could have B, E, B, BF, and then do the same thing for C, right? So then we'd have 9 different strings. And so basically you can tell that this problem, right, like writing out the solution like this, it's not that difficult because we're gonna basically be forced to brute force this problem, and it's a backtracking problem because we have to brute force it, right? We have to basically find every single combination that we could get using the given digits. And you might have noticed I've been doing a lot of backtracking problems recently, and that just goes to show you that backtracking is a very important algorithm. So let me just show you kind of the drawing of the backtracking solution. So luckily for us in this case, we're only given 2, 3, right? And so we only need to find, okay, 2 maps to these 3 characters, 3 maps to these 3 characters, but we know in total, it's possible we could have a 4, we could have a 5. If we had a 4, we know 4 maps to the next 3 characters after this, so G, H, I think, unless I'm forgetting something. And basically, we could have any character, right, from 2 through 9. So we're going to need to create a hash map or some kind of way to map every character from, or basically every digit from 2 all the way to 5, 6, 7, all the way to 9, right? And map them to the characters that they end up being, right? We know 9 is, I think, going to be X, Y, Z. We're basically going to have to hard code this map of characters. There's not like a clean way to do it, mainly because some of the characters, I think 7 has 4 characters, right? 7 is mapped to 4 different characters, and so whatever. But this is a pretty small hash map, right? So it's not a big deal if we have to hard code it. But now let's just look at this problem itself. How are we going to solve it? Well, so the first character is 2, right? So 2 could map to 3 different characters. So 2 being the first digit, it can map to A, B, or C, right? And the next character we know, or the next digit, is 3. So from A, we could have 3 different characters that follow after it. We could have a D, we could have an E, or we could have an F. And that's going to be true for every single one of these, right? We could basically put a D, E, F after each of them. And this is the entire backtracking tree. So based on this, what's our solution? Because remember, we want to know the strings that this could map to. Well, this is one string, this is one string, this is another string. So basically for each of the leaf nodes in this tree, we're going to follow the entire list of characters that came before it. That's going to be the output strings, right? AD, AE, AF, and so on, right? BD, BE, BF, and the exact same thing for C. So when you visualize it like this is actually a pretty simple problem. So now you just need to know how to write this backtracking algorithm, and I'm going to show you how to do this recursively. But before I do that, the time complexity for this is basically the number of combinations that we're going to have. So the question is, how many different outputs could we have for a string? Let's say the input string is length n. How many different outputs could we have? Well, since we know that there are some characters, like I think 9 maps to 4 different characters, I think W, X, Y, Z actually. So the brute force is going to be 4 to the power of n. That's how many outputs we could actually have, right? Because maybe we'd get a string s equal 9999, right? So basically we'd have 4 choices for each of those characters. So 4 times 4, basically 4 to the power of n, which is the length of the input string, right? So that's the number of output strings that we're going to have. And the length of each output string is going to be the same as the length of the input string, right? So really, the time complexity is going to be big O of n times 4 to the n. And basically, this is the worst case time complexity. Okay, so now let's get into the code, which is going to be fairly short. So the first thing we want to do is have a result. This result is going to contain the combination strings that we're trying to build. And the next thing we want to do is create a map of digits, right? We want to take every single input digit that could be possible, like 2, and map it to the characters that are possible. So A, B, C, right, for 2. And unless you want to see me type this out, I think I'm just going to copy and paste it. So this is what our digit map is going to be like. And you can verify this if you have an old phone laying around, that this is the correct mapping from digits to the following string characters. So now let's write that backtracking function. It's going to be a recursive function, and I'm going to declare this function inside of this function so that we don't need to pass in these parameters every time we call this backtracking function. And we also don't need to pass the digits that we're on. I'm only going to pass in one variable I, which is going to tell us what index we're at in the digit string that we're given as the input to our function. And I'm actually going to pass in one more variable, so the current string, meaning basically the current string that we're building. So let's say our input was 1, 2, 3, and the current string would contain something like A, right? So if we've only visited 1 so far, we'd have A, and then we'd want the next 2 characters from 2 and 3. So we know the base case is if I is greater than or equal to the length of digits. Or actually, an even better base case would be our current string. Let's say the length of the current string is exactly equal to the length of digits. That means that we've basically been able to take every single digit and then map it to a character, because current string is going to contain those characters. And if that is the case, then we are allowed to take our result and add to it the current string that we just built. And then since this is the base case, after that we can just return. If this is not true though, that means we haven't finished building the current string. That means we need to continue going through the digit that we're at, right, at index I. So let's create a loop to do that. So basically, I'm going to take digits of I. That's going to tell us the current digit that we're at, right? And I want to take this digit that we're at and I want to map it to the list of characters that it maps to, right? So if we had 9, we know 9 maps to W, X, Y, Z. So how can I do that? Well, that's why we created this digit to character map. We can take a digit and then map it to a character. So digit to character, I'm going to take this digit, and now basically this is going to be that string that it maps to. And I want to just go through every character in this string. So for every single character in this string, that string that it maps to. And I want to just go through every character in this string. So for every single character in this string, I want to brute force this, right? So for every single character, I'm just going to call backtrack. I'm going to make that recursive call, right? So for I, we're going to increment I by 1 because we're moving to the next digit. And for the current string, we're going to just take the current string that we were given and add one more character to it, the character that we're currently visiting, C. And that's actually all that we have to do. We have our single base case and we have our recursive case. You can see that the only thing that might be different for you is that our recursive call is inside of a loop. So with this backtracking function complete, now let's actually call this backtracking function. So the parameters to give it are going to be 0 for the index, and the current string is initially just going to be empty, right? But I'm actually going to need to make one last modification, so we're only going to need to call backtracking if the digits string that we're given is non-empty. And the reason is because if digits was empty, then our recursive call would be called, and then we'd execute the base case once, so then we'd end up returning this as our result. We'd add the empty string to result, but in the way this problem is defined, if digits was empty like this, if digits was just an empty string, the output that they actually want is just an empty array like this. So that's why we have to put this inside of a condition. But other than that, all we have to do is now return our result and the function is complete. So you can see that it's pretty efficient. Hey everyone, welcome.
It's 9:15. How am I already underwater?
I'm in the same boat.
Right,
I'm in an
so
actual
for
boat.
I thought Grammarly just fixed grammar. They make boats now?
It's more of a metaphorical boat, because I've been using Grammarly's AI for years to
Yeah? Ha? Anak? Tayo ko na. Sige. Pwede pa na ako. Ingat tayo. Ako. For C, digits card, digits at index I. Ah. Four. And then say keep it simple. I say keeps.
Okay, sorry for that. As you know now, we'll dive into recreating Sonic the Hedgehog 10 advanced enemy combat. So before how we tweak the function value, spin kick. Now the air dash is a move that interpolates Sonic's speed based on the charge time, and for the drop dash, we tie the release to Sonic's landing logic. The boost move is mapped to the right trigger. On the ground, it provides a burst of speed, while mid-air it also launches Sonic's